Welcome to the Explainer. If looking at a page full of decimals and fractions triggers a sudden wave of panic for you, trust me, you are definitely not alone. But today, we're building what I like to call a math toolkit. Think of this less like a standard, boring lesson and more like a mental assembly guide. We're going to transform those scary, complex math problems into easily solvable puzzles. Let's get right into it. It's incredibly common to feel anxiety around secondary level math, but here's the thing. Math isn't supposed to be this isolated, miserable struggle. It's a shared, completely conquerable experience. By focusing on mental strategies rather than just brute force calculation, you actually learn to work smarter, not harder. We're going to master this whole thing together, step by step. Okay, let's dive into this. Here is our roadmap for today. 1. Welcome to the Math Toolkit. 2. Taming tricky decimals. 3. The power of partitioning. 4. Figuring out fractions. 5. Flipping for fraction division. And finally, 6. Simplifying fraction calculations. All right, moving right along to Section 2. Taming tricky decimals. Mental methods for addition and subtraction. Now, we are so conditioned to just immediately reach for a calculator the second we see a decimal, right? But we really don't always need to. When you're adding or subtracting, try just separating the numbers out. So for 2.3 plus 7.8, just add the whole numbers first. 2 plus 7 is 9. Then look at the decimals. 0.3 plus 0.8 is 1.1. Put them together. 9 plus 1.1 gives you 10.1. Boom, done. Alternatively, you can just round it. For 13.3 minus 5.8, round that 5.8 up to a nice even 6. Subtracting 6 from 13.3 leaves you with 7.3. Then just add back that 0.2 difference you created by rounding, and you get 7.5. Honestly, it's incredibly efficient once you get the hang of it. Which brings us perfectly to Section 3, the power of partitioning, working smarter, not harder. Okay, imagine multiplying a decimal like 0.45 by 372. The standard, kind of hard way, involves drawing out a massive grid, writing down huge numbers like 13,500, and then carefully trying to put the decimal point back in exactly the right spot at the very end. It just leaves so much room for error. The smart way, though, that utilizes place value and partitioning to bypass all that heavy lifting entirely. And this brilliantly illustrates exactly what I mean. Let's take 0.06 times 3,500. Instead of doing long multiplication, just write the decimal as a fraction, 6 over 100. Then, rewrite the whole thing as a division problem, 6 divided by 100 times 3,500. And because you can do this in any order, divide 3,500 by 100 first. That instantly gives you 35. So now you just have 6 times 35. You can partition that into 6 times 30, which is 180, and 6 times 5, which is 30. Add those up for a super easy 210. How cool is that? Now, if you need to divide a decimal by a whole number, there are really just 3 foolproof steps. First, use the classic short division or bus stop method. Second, keep the decimal point exactly where it is in the original question. And third, write the decimal in your answer directly above it. So for 4.86 divided by 2, divide the 4 to get 2, carry that decimal straight up, divide the 8 to get 4, and the 6 to get 3. The answer is 2.43. Perfect alignment just keeps the whole thing incredibly simple. All right, we are halfway there. Section 4, figuring out fractions, understanding the basics. Now, what's really interesting about this slide is, well, fractions have literally intimidated students for millennia. Fun fact, the word itself actually comes from the Latin fractio, which means breaking into pieces. But get this, as early as 1800 BCE, ancient Egyptians were already using them. To show that they were writing a part of a number, they drew a picture of a mouth, which literally meant part, right above a number hieroglyph. So a mouth symbol drawn over 3 vertical lines, that meant 1/3. Pretty amazing, right? But look, before we can tackle any advanced calculations today, you absolutely must know how to order fractions by size. And you have 2 really reliable methods for this. First, you can find a common denominator. Like comparing 2/3 and 4/5 is super easy if you write them both out of 15. You end up with 10/15 and 12/15, making it completely obvious which is bigger. Your second option, of course, is to simply convert them both into decimals using division. Moving right into Section 5, flipping for fraction division, the ultimate tool. Okay, dividing a fraction by a fraction is historically one of the absolute most feared topics in all of math. But I promise you, it relies entirely on one vital concept, the reciprocal. A reciprocal is simply the fraction you get when you turn a fraction completely upside down. That's it. So the reciprocal of 2/3 is 3/2, and the reciprocal of 1/6 is 6/1. So Let me ask you, how many 1/6 are actually inside 2/3? Visually, if you have a space that is shaded 2/3 of the way, how many individual 1/6 blocks could fit inside that shaded area? Rather than having to draw out complex diagrams every single time you face a division problem like this, you can literally just use the reciprocal. So the crucial point is really these three golden rules for dividing fractions. Rule 1, find the reciprocal of that second fraction. So 1/6 simply becomes 6/1. Rule 2, change the division sign to a multiplication sign and just multiply straight across. 2 times 6 is 12, and 3 times 1 is 3, which gives us 12/3. And finally, Rule 3, simplify. 12 divided by 3 is exactly 4. So just remember, flip the second fraction, multiply, and simplify. Easy as that. And our final section, Section 6, simplifying fraction calculations. Factors are your friends. Listen, when you're dealing with big numbers, factors really are your best friends. Say you need to find 1/4 of 600. Don't try to divide the whole thing by 4 all at once in your head. Break that denominator down into its factors. 4 is literally just 2 times 2. This means that finding 1/4 is exactly the same as having a number and then just having it again. Half of 600 is 300. Half of 300 is 150. See, you've just turned a complex math problem into a really quick, painless mental step. And this table really summarizes our whole toolkit perfectly. For 1/4 of 600, factors let us have it twice to get 150. But look at 3/5 of 120. Dividing by 5 in your head can be kind of annoying, so instead, replace it with an equivalent fraction. 3/5 is exactly the same as 6/10. Now just divide 120 by 10 to get 12, and then multiply by the numerator, which is 6, to get 72. By utilizing equivalent fractions and factors, you can literally bend the numbers to your will. So I have to ask, which tool from your brand new math toolkit will you use first? Are you going to partition your decimals? Or maybe use the reciprocal to flip those tricky fractions? Because once you stop just memorizing random steps and actually start seeing the logical patterns underneath, math completely stops being a chore. It becomes a language you can fluently speak. Thank you so much for joining me on this explainer. Keep breaking down those complex problems. And hey, please hit that like button, share this explainer with a classmate who might need it, and absolutely subscribe for more.